Hello friends, welcome back after a long time. Hope you all are well. Now we are starting a new series here called 5G series and our fundamentals. So here in this we will start from the basics and we will cover as much as we can, not in a single lecture, but we will take multiple lectures for this. Uh, Hello, I think I don't know whether it was mute or not, but yeah, right now I think it's okay. So we are starting a new series, 5G series. So we will cover starting from the very basics. Okay, so let's start. Okay, so what is 5G? Right, as we have heard this term 5G, we can say NR also. When we say it is, these are few terms that are being used here. So 5G is fifth generation mobile telephony. NR we call next generation radio, or this is called next generation core, NGC. So these are few common names which we keep hearing from here and there. So let's start from the very basics. If we will see, like, we came across first generation. Okay, in that first generation we had analogous speech only. I'm just covering from very starting so that you get. Then it came second generation, or we can say that 2G. In this second generation, digital, right, digital telephony came plus data rate. Data rate came, okay, through GPRS or edge. Okay, then came the third generation, which we can also say WCDMA. Okay, it came in, it is also called R99 because it was released in year 1999. Right, in that HSPA came, right, HSPA plus HSUPA and all came in this. Then fourth generation came, what we call LTE, 4G, right, it means higher data speeds came, it is called release 8. It came in this release came in 2008. So then evolution went keep happening in this, and R release 15, right, we came across, a new release came in as R15. That is, we can say NR, or 5G, we can say EMBB, enhanced mobile broadband. These are few use cases. MMTC, sorry, MTMC, that is a machine to machine communication, machine to machine type communication. Then URLLC, ultra low, ultra reliable low latency communication. So these are few use cases of 5G. So this is how it all happened, the evolution happened from 1G to 5G. Now, what are few key points of 5G? When we say 5G, so what is the difference between 4G and 5G? Already we are having good speed, good data speed and all, but what is the difference when why do we need 5G? What are the use cases of 5G? What are the uses of 5G that we can have, right? So 1 minute. Right, okay. Yeah. Okay, so yeah, so I mean the main use cases of 5G are EMBB. This is enhanced mobile broadband. It means that whatever speed we are getting, downlink speed, uplink speed in 4G right now, we will have much higher speed than that in 5G. Second one is machine to machine communication. I mean, this is the use case where we will enable or we will connect our machines. I mean, suppose we have a factory layout, and multiple things are controlled by humans or multiple machines or computers. So we will connect those all machines through 5G network, so we can control them from anywhere, like the coordination and all, everything machine to machine type communication, like smart metering as well. We can include in that, like so many things. We can connect our AC through our mobile phone. We can switch on from anywhere like this. And one is ultra reliable low latency communication. That is, ultra reliable means the latency is so less in that it would be mainly used in critical cases, like surgery. Suppose somebody wants to do a surgery remotely, so that there should not be any delay, right? Otherwise it could be fatal. So in those type, or you can say remote driving kind of thing, a car is being driven by something, auto driver and all, like these kind of traffic signal and all like this. So like ultra reliable low latency communication. So these are few use cases of 5G, that is mainly why the 5G is required, right? Now we will see the performance boost, or what are the main features of 5G. What would be the main features of 5G? When we say 5G, what would be the main features? Okay, so we can say in that 20 Gbps downlink peak rate, that is what is expected. Latency is expected less than 1 millisecond. Mobility is 500 kilometer per hour. That is the mobility. We can expect any UE moving at this speed, right? And is still having good performance. The density would be 1 million subscribers per kilometer square. This is the density of UE, right? Then uplink speed, we expect 10 Gbps uplink speed. Position accuracy, we expect 1 meter position accuracy. 99.99% availability, right? And greater than 10 years battery life. So these are the theoretical, you can say, milestones we have set for the 5G. Few are practically not possible, like this is not possible, but these are the benchmarks, these are the milestones have been set by the bodies, standardizing bodies, that these should be the criteria. Then we can say that yes, we have the 5G. Okay, so let's start. So okay, now you might have heard about 5G, that millimeter waves. Okay, you might have heard about millimeter waves. So what is millimeter waves? I mean, above 6 gigahertz, we can say high bands. I mean, bands we can divide. If we have to divide the bands, we can divide that less than 1 gigahertz low band, from 1 gigahertz to 6 gigahertz, we can say mid band, and then above 6 gigahertz we can say high band. Okay, so now we want to bring 5G in high band. I mean, most of the time high band or mid band, because why do we need high band or mid band? Because low band is almost full. Like we don't have a what do you say capacity, you can say, in low band. It's almost full, right? It's being used by operators and all. And this we have some space in mid band and high band, mainly in high band. So because we will bring 5G in high band. So high band, what is the property? If we have high frequency, the wavelength would be short. If we have a high frequency, wavelength would be short, and the wavelength would be short, obviously the reachability. That's why we say that at high frequency, the reachability of site, okay, the coverage of the site would be less. I mean, if we have a low frequency, we can have a higher coverage. If we have high frequency, we will have a low coverage. Okay, this is a concept of wavelength and frequency. So that's why we will need, because since we will have less coverage, so we will need few techniques and all, which which will help us to have a good coverage and capacity, because we are using high band. So in high band we will have a huge path loss is too much in high band. So to overcome that, we will use few techniques that we will discuss later. So we will continue from here only, not too much. Okay, so if we will have to understand, then we have to understand that the relation between coverage, capacity and latency. So if suppose this is the pyramid of coverage, right, capacity, it means here coverage is high, and here this is, I mean, this is in reference to higher frequency band. Okay, higher frequency band. So this is coverage, this is capacity. So in higher frequency bands, like when we will, this is low band and this is high band. So when we will go from, low band to high band, okay, the coverage will shrink and the capacity will increase. Okay, capacity will increase. Capacity means, like, I mean, how many UEs we can serve. And after that, this is latency. So this is high band. So latency is more in high band and less in low band. I mean, these are the relations, pyramidal relations of this high band and low band. So fine. So now, how the 5G will come, and what is the NR and how it will come. So if we will see, let's start from here, that 5G will not come complete 5G together. Okay, like when it was 3G, then 3.5G came, right? Then 4G came. From 3G to 4G didn't come directly, right? So like this, 5G will not come directly. First, there are few versions of 5G. First is NSA, sorry, NSA, and the second version is SA. So what is this? NSA means non stand alone. SA means stand alone. NSA means that non-standalone 5G. It means that not complete 5G. And standalone means complete 5G solution, starting from everything, core, the radio, everything, right? So what is NSA? So first NSA will come, right? First NSA will come. So we will discuss about NSA. First, what is NSA? Non-standalone. As the name is suggesting, I mean, it's not standalone. So how the structure of the NSA would be? Suppose this is the core, right? Here, this is LTE site. Here, this is G node B. This is UE. So, like this. In NSA, this one S1C control part. Control part, if we denote it by the red color, okay, if we denote it by red color, then the control part will also be, I will write it right, S1C. Control part will also be through E node B, 4G. This is 4G. E node B, this is 5. When we say, just remember it, when we say E node B, it means E node B means 4G BTS. And when we say GNB or G node B, it means 5G or NR BTS. Okay, so control plane will always be through LTE in this case, and this is XN. It could be X1CN, XNU, and the user plane could be through this one, through LTE. It could be through this also, G node B also, right? There is a choice, there are options. This is called option. There are something called option in 5G. I mean, what are the options of connectivity in SA, NSA? So this is option 3, right? This is option 3. In option 3, control plane would always be through LTE, E node B, and the user plane could be through this one, could be through both, and could be through G node B, like any, right? So if we expand this option, I mean, in option 3 there are 3 versions: option 3, option 3A, and option 3X, right? So in option 3, if this is the core, okay, this is E node B, this is G node B, this is UE. So the control plane will always be through this one, E node B, so E node B, and the user plane would be through this. That is called option 3. In option 3A, this is core, this is ENB, this is GNB, this is UE. So control plane will always be through this one, E node B, and the user plane would be through both. Both means that the segregation of user plane will happen at core end, at EPC. Okay, core. I mean, there will be 2 ways, here also S1U and here also S1U. And in option 3X, it would be core, E node B, GNB, UE, control plane will always be through ENB, and the user plane will be through G node B, like this. This is option 3x, right? So what happens if we discuss about initially what will happen, that we already have our EPC core, we already have all our LTE network deployed, right? So if we will go completely, all of a sudden if we will go completely for SA solution, then for SA means standalone, I mean complete solution, we will have to change EPC with 5GC, and we will have to change all LTE sites with G node B. So it will be very costly solution, right? A very costly solution, and maybe that we will not be able to you can say uh, utilize the network, or we will not be able to what you can say that what are the expenses we have done, we will not be have that much traffic. So that's why we will not go all of a sudden to complete 5G solution. Instead we will go to NSA solution. In NSA solution we will use our existing core network, that is EPC core, but with some software upgradation, we can say upgraded. We will use upgraded EPC, and we will use our E node B, and then we will use our G node B with that, like this. We will have first NSA solution. So if we will talk about options, like what all options, because you might have heard this term option and all. So let's see what what are the all options are there in you know NR 4G or 5G. Oh, sorry, 5G. So options, we have option option 1, 2, 3, 4, 5 and 7. What is option 1? Suppose we have our existing network EPC, and then we have our LTE, I mean E node B network, that is called option 1. Okay, now we have our new 5G core. Okay, in that we have option, we have NR. NR means G node B connected in that. So that is called option 2. Finally, everything has to be on option 2 finally, but not all of a sudden. Slowly it will go. Then what is option 3? Option 3 is when we have EPC upgraded and we have our LTE, and through LTE we are serving GNB, that is called option 3. Okay, now option 4, we have 5GC, then we have NR, and we are anchoring LTE through NR in 5GC, that is called option 4. Okay, now in 5GC if we connect LTE or ENB, that is called option 5, right? And if we connect LTE and then we serve GNB here, that is called option 7, right? So these are various options that we can have, you know, in EPC, 5GC, LTE, GNB. These are various options, but ultimately we have to achieve option 2, right? Because this is the ultimate option with complete 5G. But we will not go for it all of a sudden. First we will go for option 3, because right now these two things we are already having. Just we have to add NR, GNB with LTE to serve, NR in few few locations where the demand is more, high populous area or high traffic area, or some kind of a mall where we have, high data rate demands. There we can serve, right? So these are various options that we tell what is in 5G. So basically you can say that what are the characteristic of what are the characteristic of 5G network here. So yes, as I had already told that these are the properties of 5G, that main, that as theoretically we have set the standards, right? So few things are not possible. This is not possible. Battery life greater than 10 years, but yes, we have set it. So let's see. So here, these are few things that just the very basics of 5G starting and all. And here, you know latency and all, these are the main things, theoretically 5G, what we can have. So later in coming sessions we will discuss more about, slowly we are starting, if all of a sudden not going in very depth. So we will discuss 5G, what are its physical layer structure, how is the physical layer, numerologies. You might have heard about these terminologies: numerologies, physical layer structure, OFDMA, and DFT, time slots, subframes, and all we will discuss of 5G. So these were just the introductory session of 5G. So okay, so we will discuss more in coming sessions. So thanks team. So let me know if you, need any other session and all on this. We will make a complete series for this. Thanks.